Okay, this video explores the idea of why do we need the graphing calculator? Why is there a calculator and a non-calculator part of the test? And it's because of these two buttons here, and they made it very simple because different people from different parts of the country, they could all have different kinds of calculators, but the simplicity of this is what we're getting at right here. And here's what all it is right here under the math menu. There's two buttons that you need to know about: end derivative and fint. You can also access those under the calculate menu here as well. So if you have any graph like x squared, so I have x squared, whoops, hit the wrong button. Oh, no, that's not going to work. Let's try this again, x squared. And we graph the old zoom and 6, zoom standard. There's the parabola. You can also access those two things under the calculate menu. So you have second calculate, and there's that one, which means derivative, and then the area under the curve. So we're going to go through these both ways. All right, so here we go. My function is just f of x is equal to x squared. So the derivative would be 2x. So now I can plug numbers in. F prime of 1 would equal 2. F prime of 2 would equal 4. F prime of 3 would equal 6. F prime of 4 would equal 8. So that would be getting the derivative of all these. So there's the derivative, plugging 1 into the derivative 2 and all that kind of stuff. Well, the calculator will do that for us. So here's how we do it. So I'll put this side by side here. So I have the functions already programmed in. There it is. So go back to the home screen, hit math, and we're going to do the end derivative. So the end derivative, we just do x, and we put in the function x squared, and the place where we want to know the derivative. So the first place I want to know the derivative is at 1. So I'm doing the derivative of this, plugging in 1. The answer should be 2. Enter 2. Up. I can find the derivative anywhere I want to go. So now I'm going to do 2. So the answer is going to be 4. Okay, and then I'll put in 3. And the answer is going to be 6. And then I'm going to put in 4. So go up. And then put in 4. And there's 8. So 2, 4, 6, 8, just like I have here. Now I'm going to do it from the graph. So I'm going to go to y equals and graph. And there's the graph. So under calculate, second calculate, that means derivative, right? So I want to know the derivative certain places. I want to know the derivative at 1. So I type in the number 1 and I hit enter. All right, so at 1, 1, the derivative is 2. Well, there it is. Okay, I believe, I think I have to hit that again, because if I hit 2, enter, it's just going to take me to the point 24. It won't tell me the derivative. So you have to do second calculate again, and then do number 6, and then put in 2. So 2 comma 4, the derivative is 4, which is what I have right there. And then second calculate derivative, put in 3. So 3, 9, the derivative would be 6, which is what I have right there. And then this is going to be off the screen, but it should still tell me the answer. Second calculate derivative and 4, enter, 16. So at 4, 16, the derivative is 8. But it's off the screen, so you can't see that. And of course, you can put negative numbers in here and know that that side's negative. All right. So the second thing is finding the area under the curve. So to find the area under the curve, we do integral, and we'll just do positive numbers here. We'll go 0 to 1 x squared dx. So this will so the answer to this is going to be a number that we can get, and then the area under the curve function on the calculator will just tell us the answer. So the antiderivative, of course, is 1/3 x cubed. Draw your line 0 and 1. Putting in 0 is easy. Putting in 1 would just give us 1/3. So the answer is 1/3. If you did integral 0 to 2 x squared dx, it would still be 1/3 x cubed, line 0 and 2. Put in 2, that would be 8, so it would be 8/3. And then you could go 0 to 3. Integral 0 to 3 x squared dx is 1/3 x to the third, 0 and 3. Put in 3, that would be 27 divided by 3 is 27 divided by 3 is 9. So the answer is going to be 9 for that one. Okay, well, let's have the calculator show us these answers. So we go to y equals, still going to be there. Okay, and clear. So this is the other key that's very important to us, is the fint key. So we put enter. Fint, so we're going to go 0 and 3. No, 1. 0 to 1 first. And the function, you can put in x squared, or since I already have it typed in, you can do y1. So you can put in y1 or x squared with respect to x. Oh, you have to respect x always. And the answer is 1/3, 0.3 repeating. So you have to interpret it that way. Up arrow, enter. And now we're going to go 0 to 2. So it should be 8/3, which would be 2.6 repeating. And then up arrow, and then go in here, change that to a 3. The answer should be 9. 9. So there's all the answers there. Now if you do it from the graph, so we hit the graph button here, and we hit second calculate, and we're going to do number 7. And for the lower limit, it asks you to put 0 to 1, and then 1. And it shows you that little bit of area right there, and then the answer is 0.3 repeating. Second calculate, and we can go 0, enter, 2, enter. So it's going to show us a little bit more area. So it's going to be that. And then second calculate, you have to do it each time. Enter 0 to 3, whoop, and that would be an area of 9. Man, these things calculate really fast. So that's basically the 2 buttons that you need to do these. Now, obviously, for x squared, no big deal, right? For x squared, it is no big deal. We can do polynomials all day long, finding the area under the curve, taking the derivative, easy. X squared is like the most basic curve function there is. However, what if you had something like this? E to the x, natural log x, sine x, right? And y equals. Okay, do you want to take the derivative of that? No. Do you want to find the area under that curve? No. What's the antiderivative of that? I don't know. But you can type this into the calculator, and then you can, estimate the area under the curve by having it fill in all the little pixels, right? So it fills in all the little pixels, and that's the area under the curve. So that's the, it's for functions that we don't know how to deal with. And that's what they give us on part of the AP test, are functions that we really can't take the antiderivative easy of, or they just want to speed up the process so we don't have to sit there forever and do it.